We live in the Milky Way, a galaxy that contains 100 to 400 billion stars. But even though we live inside it and can observe an incomprehensible number of stars strewn across the night sky, we actually know very little about the galaxy around us. But last week, the European Space Agency increased our knowledge of our place in the universe a tiny bit with a torrent of stellar data from the Gaia spacecraft, a catalog of star data covering 1.7 billion stars, approximately 1% of the stars in our galaxy. And not just stars, but asteroids, exoplanets, dark matter, quasars, satellite galaxies, and more. It's safe to say the data released by Gaia is going to keep astronomers busy for decades, and it's just getting started. For the last 22 months, ESA's Gaia mission has been exhaustively charting the sky in all directions, making precise measurements of stars, including their position in the sky, distance, and motion through the galaxy. This has allowed astronomers to create the most precise map ever made of the galaxy. I want to show you a photograph now. It's the Milky Way, right? Wrong. This isn't a photograph. It's an all-sky image of the Milky Way and its satellite galaxies made out of Gaia data. The brightness of the pixels correspond to the number of stars located in that exact region of space. The bright area through the middle of the image is the galactic plane, which we're embedded inside. You can see the small and large Magellanic Clouds below the plane, which our lucky Southern Hemisphere friends get to see. The darker regions contain gas and dust, many of which are hiding regions of star formation. This is a map to our home, the most accurate map humanity has ever made of the cosmos. Just for comparison, here's the 2016 version of this map produced by Gaia. I think the new one looks much better. The European Space Agency's Gaia mission was launched in 2013 with the goal of gathering specific data on this huge number of stars in the Milky Way. The spacecraft was launched to the Earth-Sun L2 Lagrange point, which is a relatively stable spot beyond Earth orbit. The spacecraft takes about 180 days to slowly orbit around this spot in space while following the Earth around the Sun. The position far from the Earth allows it to see as much of the night sky as possible without our planet getting in the way. And from this vantage point, it catalogs the Milky Way stars using astrometry. Now, just a quick explanation about astrometry. As the spacecraft travels around the Sun, its perspective to the stars in the sky shifts slightly back and forth over the course of 6 months. The amount of this shift is incredibly small, but Gaia can detect it. Now, let me give you an example. Here's a loonie, a Canadian $1 coin. For the brightest stars in the sky, Gaia can detect that back and forth shift over 6 months if that coin was sitting on the moon. So about a 25 millimeter shift at a distance of 385,000 kilometers. The spacecraft can then use this shift to plot out how far away the star is. The more it shifts, the closer it is. It can also determine what direction the star is moving. On April 25th, ESA dumped this massive amount of data onto the internet, the location and distance of all these stars as well as their color measurements. I'm sure this will be very useful when someone makes a map of the real galaxy in Elite Dangerous. It also calculated the surface temperatures of about 100 million stars and how much 87 million of them are being obscured by interstellar dust. But that's not all. Gaia also provided brightness and color information on 500,000 variable stars. These are stars that change in brightness over time, and astronomers regularly use it as a way to measure distance in the universe when astrometry doesn't work anymore. In other words, in addition to mapping out the nearby universe, it helped astronomers have a way to better map out the rest of the universe too. Are you overwhelmed with data yet? Good, now you know what it's like to be an astronomer right now. But Gaia provided even more information about the universe around us, and we'll get to that in a second. But first I'd like to thank Adam Hajinian, Ben Fleming, and the rest of our 808 members for the generous support. If you love what we're doing and you want to get in on the action, head over to patreon.com/universe today. Gaia did its job well. It showed us where all the stars are, but it did even more. The first useful side effect from Gaia was the release of data on 14,000 known asteroids. From these data, astronomers will be able to map the movements of these asteroids with greater precision. For example, to find any asteroids that might have a close encounter with Earth in the future. Gaia mapped the locations of 500,000 quasars strewn across the universe. Quasars, of course, are the actively feeding supermassive black holes in the hearts of galaxies. Our Milky Way's black hole is relatively quiet, while these distant black holes are blasting out as much radiation as the rest of their galaxy combined. This is a handy side effect, but it also provides astronomers with a single reference frame for the coordinates of everything in the entire Gaia catalog. Now, I want to show you another image. This is known as the Hertzsprung-Russell diagram, and it's a way that astronomers can map out the brightness of stars compared to their surface temperature. Except, this diagram is made up of the actual data on 4 million stars located within 5,000 light years of the Sun. The precise map of the actual stars around us is going to help astronomers make tweaks to their theories about stellar formation and evolution, which stars formed in the disk and which formed in the halo, and how are they different. Are you exhausted yet? Well, too bad, there's more. For about 7 million stars, Gaia was able to calculate their velocity in 3 dimensions. Astronomers will know where these stars were in the past and where they're going in the future. We'll know which stars can make a close pass to the Sun in the distant future. If you've memorized your constellations and plan to live forever, too bad, they'll get all jumbled up millions of years from now. Check out this animation of the globular clusters and dwarf galaxies surrounding the Milky Way and their orbits. And here's a bonus. Take a look at the motions of the stars in the Large Magellanic Cloud, one of those satellite galaxies adjacent to the Milky Way. And if astronomers are lucky, they'll be able to detect the distribution of the dark matter that's probably all around us. Finally, here's the best news. Gaia is not finished. It's due to wrap up its primary mission in 2020, providing as much data as it can by then. One additional chunk of data coming that wasn't included in last week's release is the fact that Gaia is expected to find between 10,000 and 50,000 extrasolar planets. So right now we're at about 3,700 confirmed planets, so that's not bad as a side effect of this mission. Gaia will also find tens of thousands of brown dwarf stars. These cool objects are somewhere in between really big planets like Jupiter and failed stars, and help astronomers know how many of them could be out there. In addition to the known asteroids and comets mapped out in this data release, it should eventually map out hundreds of thousands of these objects, from near-Earth orbit to the asteroid belt to the Kuiper belt and beyond. It's expected to detect about 100,000 supernovae across the universe, many before any other observatories, giving astronomers their first look at these exploding stars to help understand all the different ways that stars explode. And last but not least, it'll provide a comprehensive test of Einstein's theory of general relativity, including the effects of gravitational distortion across the universe, and even detect if gravity itself is changing at all. At this point, I hope you're as excited as I am about the Gaia release, and over the next few weeks, months, years, and decades, you're going to see story after story, discovery after discovery, about what new insights into the universe we've learned thanks to Gaia. It's an exciting time, and I can't wait to learn more. Well, what do you think about the Gaia release of data? I'd love to hear your thoughts in the comments. Once a week, I gather up all my space news into a single email newsletter and I send it out. It's got pictures, brief highlights about the story, and links so you can find out more. Go to universetoday.com/newsletter to sign up. And now, here's a playlist.